All right, this is the start of topic 17. But before you do this, I do want you to be able to understand these ideas. So if you look over these, if you don't get them, go back to the topic 16 video. If you kind of get them, listen to my explanation. If you get them all, fast forward to the objectives page. Newton's first law says when forces are balanced, so when the net force equals 0, an object in motion will stay in motion, and an object at rest will remain at rest. The tendency for objects to do this is called inertia. So we use the word tendency, or desire, or we just say objects want to keep doing what they are already doing. Inertia is related to mass because if mass goes up, then the tendency for an object to stay at rest, or inertia, also goes up. That is to say, a heavier object is harder to accelerate than a light object. A light object, once it's moving, is easier to stop, so less mass, less inertia. It's easier to stop moving than a heavier object. And on to today's lesson. Given the description of motion, be able to predict the acceleration and net force, describe the types of motion that exist when forces are balanced, and two types of equilibriums. Oops. All right, first thing, here's your title, page 27. The title is Motion When Forces Are Balanced. And this is a reminder, so start writing here. We're going to do a diagram. It can be kind of big. Fill up some space with this. There's not a lot of notes today, so you can write larger. Balanced forces mean net force is 0. So when you know this, you also know this. And one more thing, there's also 0 acceleration. So when you know 1, you also know 2 and 3. Now, what type, if you know forces are balanced, what type of motion are we going to experience? Well, the first is no motion, or we call that the object's going to be stationary at rest. But one thing is we know that. The next thing is, here's a diagram. This would be an object of balanced forces with no motion. Gravity is pulling an object down. The surface that the object is sitting on is pushing up. That's the normal force. And the overall system is balanced. Net force equals 0. Two ways to write net force. Okay, another example is if you know forces are balanced, 0 acceleration, and the object is moving at constant velocity. So, force applied by the engine in this car equals the force of friction and air resistance, slowing it down. So the net force is 0, and we have no change in velocity, 0 acceleration. Okay, there's a special name for this scenario, and the first one is, it's called equilibrium, which is the sum of all forces acting on an object is 0, or all forces are equal, sort of. I say sort of because, well, these forces are equal, 2 newtons apiece, but that's not equilibrium. This is equilibrium. When the sum is 0. I go quickly because you can pause the video, so feel free to rewind or pause. Dynamic equilibrium is when forces are balanced and the object is moving. So dynamic means moving. Static equilibrium is when forces are balanced and the object is stationary. So here's some practice. So you don't need to write this down, just try to work it out. Here comes the answer. So pause right now, read it. Here's the answer. If you want to go in a straight line, and here's our big hint, constant speed. If it's moving at constant speed, acceleration equals 0, F net equals 0. So you must supply a force equal to the drag force. So here's water, here's the swimmer, and the water is trying to hold him back. This is drag. So that means we need to apply a force equal to drag in order to swim at constant speed. Some more examples. Draw these. Add the forces on the following objects in order to create equilibrium. So pause the video, draw these. After this, you'll need only about a third of a page. So this is pretty much it. Here come the answers. Balance that, equilibrium. Add 3 here, equilibrium. Add 20 up here, equilibrium. Add 15 newtons there. Another example. This is a good example to write down. So this will be our first test-like example. How much force applied by hand to create static equilibrium? Pause, look over your notes, try to figure it out. Here's the answer. Well, I need to match force gravity. Mass times g, or mass times 9.8. 10 times 9.8 equals 98. So applied force from the hand equals 10 newtons. Hey.
Hi.
Just,
Mr. Zoidis?
yep, just finishing up.
Okay. Should I wait outside?
No, you're fine.
Okay.
Okay, so the last thing I want you guys to do is add, this is a diagram that I want you to kind of finish up your notes with. You'll need this for the homework. Newton's laws are for when forces are unbalanced. First law is when forces are balanced. In this example right here, we have 2 types of motion, stationary and constant velocity. Acceleration equals 0. Sum of forces, or net force, equals 0. When forces are balanced, we have unbalanced, we have acceleration. And the acceleration is related to mass and force. Things are either slowing down or speeding up, or turning. So this is just kind of a little diagram to notice when we're talking about one and when we're talking about the other. Cheers.